Hello everyone, welcome back to my channel once again. So I hope all of you are doing so great in your life. And today we are going to start a new topic, that is forces. Okay, so all of you can take out your notebook so that you can note down the important points, and let's start it without any further delay. So in this chapter, we will be discussing about the push, pull, and the types of like the forces, what is force, then the types of forces, okay, then effects of force. We are going to discuss all of these things in this chapter, okay? And after this, we will be also discussing about the Newton's laws of motions. All right? So stay tuned and please do watch the complete video. Okay. So in this image, what you can see, so question is like which images are showing like pulling force? A, B, C, D. Guess the answer. What are the pulling force? And I hope you have already imagined your answer. So next question is now what are the pushing force? A, B, C or D? What are the pushing force? So here you can see this girl is like pulling her bag. So this is the pulling force, right? And this boy is also pulling the bell, the thread of this bell. So this is also the pulling force. So option B and C are the pulling force and option A and D are the pushing force, right? So when we are closing a door or we are opening a door, so what we do while closing the door, we push it, and while opening a door, we are pulling it towards us, right? So when we are moving something away from us, away from ourselves, that is called as the pushing force. And when we are moving something towards ourselves, that is called as the pulling force, like you can see here. What this boy is doing? This boy is just pulling this trolley, right? And this guy is pushing this trolley. Okay, so this is pull and push. Now what is force? So force is something pull and push only, right? So when something is moving, that is pull, moving away, that is push, and when something is pulling towards us, that is also force. So we are applying force to move some object away from us or towards us, right? So we have to apply the force to move some objects, right? Okay, now my next question would be, suppose your like you are sitting on a chair, so your chair is lying on the floor and the chair is not moving. So is there any force applied on your chair also? Or suppose you are not only sitting, suppose for another example, your pencil box, you have kept your pencil box on the floor, okay, and your pencil box is not moving. Is there any force applied on the pencil box also? Just think about it. So basically, force is something push or pull upon object resulting from interaction with any other object. Okay, so it's it's a push or pull upon an object resulting from the interaction with another object. That is force. Okay, now this is not necessary that a force is always going to move an object. It's not necessary. Like I just give you the example of a pencil box you have kept on the floor. It's not moving. But is there any force applied on it? So the correct answer is yes. It's not moving, but still gravitational force is there, frictional force is there, right? But the object is not moving. So force can affect the object, can affect the motion of an object, but it's not necessary. Okay? So force can affect the motion of an object. That's the second point. But it's not necessary. If an object is stable, then that also means there is some forces applied on it. Now, how that is like how that is happening, how that's possible. Let's see this. So basically, there are two types we can say: balanced force and the unbalanced force. Okay, like have you ever played the tug of war? right? In your like in your school, in the any sports activities, have you ever played the tug of war? So what happens if like equal number of peoples are on the two sides, let's suppose this is our A team and this is our B team. So both the team should have equal number of people, three people here, then three people in the B team. So suppose both the teams are applying equal amount of forces, like here it is saying 300 Newton forces both the team are applying. So what will happen? Tug is not going to move in any direction. It's going to stay in that position only. No team can win if both of them are applying equal amount of forces. But suddenly A team started to apply a more force like 400 Newton, but B team is still in the 300 Newton. What will happen? A team will win. So tug will move in this direction, towards the A team, right? So first is the example for balanced force and second is the example for unbalanced force. Okay, so a object will be in motion only when there is a unbalanced force. Otherwise, if there is a balanced force, object will be at rest only in that particular position only. I hope this is clear to you. So here you can see and you can take the notes of this. A balanced force are applied to a object. There will be no net effective force acting on the object. Balanced force do not cause change in the motion. Whereas unbalanced force acting on the objects, it's change its speed or the direction of the object and like the it moves the direction of the force to with the highest magnitude. All right, so that object is going to move towards where the force is having highest magnitude. So unbalanced force is the force which basically cause the motion. Balanced force do not cause any motion. Okay, now, here comes a term called as net effective force. What do you understand by net effective force? Basically is. So, net force is when multiple forces are applied on a body, they can be resolved into one component known as the net force acting on the body. For example, in this picture only, if we say 300 Newton towards the A side, 300 Newton towards the B side. So net force will be 0. That's why this is balanced. That's why it's not moving. Okay. But here 400 newtons towards the A side, 300 Newton towards the B side. Net force will be 100 Newton towards the A side. Okay. In this picture, in this diagram, you can see here 500 Newton is applicable. This is the frictional force. It's applied towards this direction. Sorry, not 500, 50 Newton. But when we are driving a car, when we are starting the car, we are accelerating the car, that force is more than the frictional force. That is 200 Newton. So net force is 150 Newton and that's why the car is moving in this direction, in the forward direction. Okay. So this is the concept of net force. So basically you have to just subtract this, 200 Newton minus 500 Newton, that will be 150 Newton net force subtraction. But now here you can see, here you have seen that net force is applied like frictional force and the forward force is there, right? But is there only two kind of forces applicable on this car? No. Gravitational force is also applied on the car. A normal force is also applied on the car, right? Normal force, that's the perpendicular from the like ground. So this is the normal force. So the total net force will be sum of all of these forces. Okay, like Fa, which is the applied force. This is the applied force, like the 200 Newton. Okay, then Fg, the gravitational force. Ff, that is the frictional force, and Fn, that is the normal force. So all of these together will be called as the net force. I hope this is clear to all of you. Normally, in generally, what happens? Gravitational force is equals to the normal force, so it gets cancelled off. Okay, that's why like the car is not going under the earth, it's not going inside the earth. If the suppose the gravitational force would have more, what will happen? The car will go dig, it will go inside the earth only. If the normal force is more, what will happen? Car would have flied, right? But that does not happen. Why? Because it's kind of equal in number, so it cancelled off. Okay, and the frictional force and the applied force are more applicable, which we can see clearly in our day-to-day life. I hope this is clear to you. For a better clarification, let's watch a video.
Lying at rest on the ground. What is force? Let me tell you what you will probably read in your textbooks. Force is a push or pull upon an object, right? Though this cannot be really classified as incorrect, it hardly explains anything about the concept of force. This is what you will assume after reading this definition. You will imagine a stationary object on the ground and someone pushing it or pulling it. Yes, when force is applied, the stationary object will move, but just this does not explain the concept of force entirely. Before we move on to the definition of force, let's clear a few misconceptions about it. Let me ask you a question. This ball is lying at rest on the ground. It's stationary, not moving at all. Is there any force acting on it? Listen to my question carefully. Are there any forces acting on the ball when it is stationary? If your answer was a no, or if you didn't have an answer, it means you don't know the concept of force yet. The answer is yes. There are forces acting on this ball. There is a gravitational force which is trying to pull the ball towards the center of the earth. And the ground is applying an equal force exactly in the opposite direction. This force is called the normal force. Because these two forces are balanced, they do not change the position of an object. The net force acting on the ball is zero. So what does this tell you? Just humans pushing or pulling is not the only kind of force. And just because there are forces acting on an object will not mean the object will move. For the object to move, there has to be some net force. So now let's say a person softly kicks the ball. What happens then? Yes, the position of the ball changes. Why did the position change? It's because there was another magnitude of force acting on it, and this time the forces were not balanced. The ball moved and there was displacement. But hold on, why did the ball stop moving after covering 15 meters? The ball started moving at a pace and then slowly came to a halt. If there's no force from the other side to stop it, how did it stop? Was there a force which stopped it? Yes, it was friction that stopped the ball. While the force you applied was towards the right, the force of friction was towards the left. Let's make it even more interesting. Assume your screen to be a frame of reference in this example. Also assume that this straight horizontal line is a frictionless flow and there's no air resistance. The ball appears from the left of your screen and moving towards the right at a uniform velocity of 2 meters per second. The only two forces acting on the ball are the gravitational and the normal forces which net each other out. In this setting, will the ball ever stop moving? No, it won't. It will continue to move along the same path at the same speed unless there is another external force which acts on it. Here, as the forces are balanced, the ball will continue to move at 2 meters per second. Most people assume that if the object is moving, then there is some net force acting on it, but that's not true. An object will continue to move at uniform velocity even if the net force on it is zero. So there are two things we've learned here. First, if the object is stationary and the net force acting on it is zero, then it will continue to remain at rest. Second, if the object is moving at uniform velocity and the net force acting on it is zero, then it will continue to move at that same uniform velocity. Now, when this ball is moving at 2 meters per second and there is an external force applied from the left, what will happen? Yes, the ball will accelerate. Its velocity will change. Let's say the velocity changes to 3 meters per second after this external force is applied. After that, the ball will continue to move at 3 meters per second unless acted upon by another external force. So nobody's really seen or touched force. It can only be understood by knowing what happens to an object when force is applied to it. If the body is stationary, do not assume that there is no force acting on it. And if the body is in uniform motion, do not assume that there is some net force acting on it. So what is force? A force is a push or a pull upon an object resulting from its interaction with another object. So when you kick the ball also exerts some force onto your leg. But as the force of your kick is stronger, the ball moves to the right.
All right, so that's a very nice video, and I hope you have understood the concept now. So basically, a force is something, a push or pull of an object resulting from the interaction with another object. Okay, so a force can, when we are applying a force, it can change the motion of the object. Okay, so if the, even if the object is in uniform motion, we can speed up the motion of the object, we can, or we can decrease the motion of the object. Okay, so that is the force, and force is always there. If some object is at a stable position, then also gravitational force and the normal force is applied on it. Okay, which basically cancel out each other. That's about the force. Now let's move on and let's discuss about the types of forces. So basically, we have categorized the types of forces into two types: contact forces and non-contact forces. As the term already suggests, contact means when the two objects are in touch with each other. That's the contact force. And the non-contact force means when two objects are not in directly in touch with each other or directly contact with each other. That is the non-contact force. Okay, so in the contact force, first you can see the applied force, basically like when we are using our hands to apply the force to close the door or to pull the door, for not only door, like for any pushing or pulling any object, that is the applied force. Next type is the frictional force. So frictional force is basically the force which is applied by the surface. Okay, and it is always opposite. All right, it is always in the opposite direction. All right, that is the frictional force. We will be discussing about this also in detail. Okay, next is the spring force. All right, and next up is the drag force. Drag force is basically the force which is mostly force applied by the air or liquid. Okay, or air or water, basically any fluid force is called as the drag force. So here you can see this guy is like in the parachute. So the air, when you are doing this parachute, traveling through this parachute, so what happens, the air is also acting on your body, right? So that force is the drag force, force applied by the air. Okay, and if you are going deep inside the water for swimming, then water is also applying a force, so that is also called as the drag force. All right, so all of these are the contact forces. Next up is the non-contact forces, like the magnetic force. Okay, so like there are, if you have any magnet and any substance like iron, so it can pull all those iron fillings, so it is non-contact, it was not in contact, right? So that is a magnetic force. Okay, then comes the gravitational force, which is again a non-contact force, because any object fall down, it's not in the contact with earth's surface, but still it's fall down towards the earth's center, right? That's the gravitational force. Next up is the electrostatic force. Okay, electrostatics force, especially when it is created, like if you comb your hair, like uh, it's a very bad drawing, I'm sorry. So like suppose if you have a comb, okay, and you have some pieces of papers, right? So after combing your hair, and when you bring your comb towards the pieces of papers, what happens? The pieces of paper, small piece of paper, gets stuck to your comb, right? How it happens? There is the electrostatic forces applied on it because of the charge separation. Charges are getting separated by induction. This process is called as charge separations by induction. Okay, so like paper is neutral only, right? Paper is neutral, but if I like magnify this paper only, suppose, so this paper is made up of charges. It has positive and negative charges, and that is neutral, right? Like neutral means number of positive will be equals to number of negative charges. But when we are combing this here, so the comb is developing some charges by the frictional force, because when we are combing there is a frictional force, so charge development by friction. When we are bringing this comb closer to the paper, what happens? Positive charges and the negative charges get separated. It's still neutral because number of charges are the same, so it's still neutral, but charges get separated. So that's called as the charge separation by induction. and due to this the paper gets attracted towards the comb. Okay, so that will be the electrostatic force. Again, these are all the non-contact forces. I hope this is clear to you. Let's talk about the frictional force in detail. So frictional force is basically force which is opposing any kind of motion, and it is always in the opposite direction of the motion. That is the frictional force. So suppose like here, if you are pushing this box towards this direction, so motion is in this direction, right? Towards this direction will be the motion, and frictional force will be applied in the opposite direction towards the like of the motion. Okay, so that is the frictional force. This is always applied by any surface, not only the earth, it could be any surface. Like if you are keeping something on the surface of the table, that is also surface. Okay, so there are also frictional forces applied. And why the frictional force is there? Basically because of the irregularities present at the surface. Okay, so suppose you choose a very smooth surface. If the surface is very smooth, frictional force will be very less. Okay. And if the surface is irregular or rough, frictional force will be more. Clear? So you can basically increase or decrease the frictional force also. Okay. According to your own need. All right. So suppose like if you play the carom, what happens? Yeah, like we spread some powder on the carom board, right? Why we spread the some powder on the carom board? So that the striker can move very easily, smoothly. So what we are doing, we are basically reducing the friction. Okay. So if you look, if you zoom the carom board, so this carom board is having some irregularities. You cannot see it by your naked eye, but in the microscopic view, this carom board surface is irregular. So when we are spreading the powder, what happens? Powder is getting stuck into these irregular surface and making the board more smoother for the striker. So that's how we are reducing the frictional force on the carom board by applying the powder. Okay, but let's take second example. Suppose you are doing any weightlifting or you're going to gym. So what happens? Our hands become sweaty, right? So there is water in our hands, so we won't be able to lift the objects, weights, right? Because it gets slippery. So then also we apply powder in our hands. Or you can say the cricketers, they apply powder in their hands before, especially the bowlers, before throwing the ball, especially during the summer times. So what they are doing, they are using the powder to increase the friction, because when our hand gets wet, uh, the fluid, the sweat is reducing the friction from of our hands. Okay, so that's that time we are using the powder to increase the friction. So in both the cases, we are using powder only, but in the first case, powder is used to decrease the frictional force, and in the second case, powder is used to increase the frictional force. Okay, so I hope this is clear to all of you. Now moving on, let's see the advantages or disadvantages of the frictional force. So basically we are using the frictional force in so many things, like burning the matchsticks, So there also we are just rubbing the stick into the matchbox. So we are basically providing friction, due to which it ignites the fire. So that is the advantage. We can write on the paper like your notebook. So why you can write? Because the paper is surface of the paper is a bit rough. Okay, so that there also frictional force is used. You cannot write on a smooth surface. You cannot write on the glass. All right, like you can use the now marker pens are available to write on the glass, but not the like by using normal ball pen or gel pen. You cannot write on the glass. Okay, so that is so frictional force is helpful in the writing also. Frictional force is helpful for walking or running. We are able to walk or run. Why? Because the surface is having frictional force. Otherwise, if there is any smooth surface, what will happen? We won't be able to walk properly. It gets slippery. We will fall down and break our bones, right? So these are the advantage of frictional force. Okay. Now let's see some disadvantage of the frictional force. So disadvantage here you can see, first of all, it causes the loss of energy. Okay, so if the frictional force is more, so the consumption of fuel in the car will be also more. Okay, because it will require more amount of energy to move in the forward direction. Okay, then disadvantage next is the forest fire. Okay, so if you are aware now, you can check your like news channel. So there is a forest fire happening in the Los Angeles. Okay, so how the forest fire is created? So when basically the trees in the forest gets dried up, okay, there is lack of moisture present in the atmosphere, especially it can happen during the summer days. So and the trees are rubbing with each other due to the winds, so it catches the fire. Okay, and it can be very devastating in nature. It's very dangerous. Okay, like the recent news of Los Angeles, the whole city it's burning now. Okay, so this is the disadvantage of frictional force. Other disadvantage, it could be like if like the frictional force cause loss of energy, we already discussed. So basically these are basically the disadvantage of friction, advantages and disadvantages of frictional force. And both we can use the frictional in our own way for our advantages. Okay, and there are some disadvantages also. So that's all for today's topic, students. I hope this is clear to all of you. So if you have watched the complete video, please hit the like button, subscribe to my channel, and share this with your friends. In the next class, we are going to discuss about the effects of the frictional force, effects of especially the forces. Okay, so thank you for watching my video. Okay, so take care, have a nice day. Bye bye, see you again.